Morning, everybody. Students online, can you hear me? Can you see the screen?
Yes, sir.
Good. Um, so we're gonna work through this paper, January 2019 paper, one of the papers that you guys did yesterday. And the idea is that as I go through the paper, you grade it yourself. A lot of parents have been asking about the grades. Grade it yourself. The marks are there in the paper. All right, out of the total marks, and then you see how many you got. Remember, we have a pass mark for the paper. We're making progress. Next week, the pass mark is going to jump up by 10%. Next week, the pass mark is going to be 65%. This week, the pass mark is 55%. Right? Using a strategy of progress before perfection. The idea is that you want to learn from your mistakes. So identify your mistakes. That's why I allow you to mark the paper yourself. I'm going to be doing an assessment maybe next week where you will not mark your own paper. All right? You will not mark your own paper, and those papers will be assessed to how well we're learning from our mistakes. It's very, very important that you pay key attention to these solutions. It's very, very important that you identify your mistakes, you focus on them, you redo the questions, clear those mistakes. So not doing the paper is a big disadvantage because you would not have made that mistake to be able to correct it. All right, and that's why I send the papers in the group for the persons who are not able to attend. And I say, do the paper by 11 a.m. today. You have to find time to do the paper. So if you can't come on the session here to where we're doing the paper, you have to find some time at home to do it. You have to do the questions. On exam day, you will have to do these questions yourselves. Watching me solve the questions is not enough, not good enough. Because if watching people solve questions was enough, everybody in the Caribbean would get straight A's. Because there are so many people online solving questions every day. People watching people solving questions every day. That's not enough. Almost every exam paper, you can go online and find 10 different people solving the question, as I'm going to do now. This paper, I maybe have 12 videos of this same paper, me working on this paper online on my channel. And I'm sure there are several other teachers, several other persons who do that sort of stuff, have the solution here. So watching the solution done is not enough. You can't really learn properly. You can really only fully understand maths by solving the question yourself. You have to put pen to paper. You have to do the question yourself. If it is easy to do it after I do it as if you would have, do it in the same kind of condition as you would have to do in an exam, which is do it out of your head. You have to get to that level. Yes, you do it gradually and you can look back at the solution and what have you, but eventually you have to be able to do the questions by yourself. And you cannot wait till the day before the exam. Right? You cannot wait till the day before the exam, start trying to see, if you can do the questions. That don't make any sense. You have to start getting comfortable with them from now. All right? So that is the purpose of the exercise. And I find that on a Saturday, a lot of persons not taking the thing serious enough. So from this Saturday coming, I'm going to change some of what I allow. And those are the people taking breaks and all them things. They're not going to take so many breaks in a real exam, but the sense you have to train yourself to sit down for the full 2 hours and 40 minutes in the exam room. Because when you come out of the exam and go bathroom or go buy something or whatever it is, right, you're not getting back the time. So you're not truly testing your ability to do the paper within the time. You're not truly testing your ability to spend the amount of time that is required on each question. So from this Saturday, it's going to be that when we come to do the mock exam, you sit down and you do it for the full 2 hours, 40 minutes, not giving any break. And somebody will take a quick bathroom break. It has to be that, a quick bathroom break and come back. People outside talking all them things. That don't make no sense. People on the phone playing chess and all them things they do it while they should when they should be doing the paper. Oh,
Yes.
that makes sense.
Jesus
So they're not taking the
Christ.
thing
Until
seriously
they need it, what?
because you're in a different people and not seeing you. And that's why you don't have any integrity because as soon as I have to go on the road and come back and people outside, where's the integrity? And I said, practice the management of the time yourself. I put the time on the board and I said, all right, practice the management of your time yourself. I soon come back. I had to go on the road a little bit. Right? And people outside and walk out, God, Mr. God, talk during the exam time. Oh, let me say, defeating the whole purpose of the exercise. And to me, just not smart. I just can't understand it. People just not smart. People just do things where just don't make no sense to me. If you know you're preparing for an exam and you know you're trying to work a strategy, work with the strategy. Don't go around it. There's a reason for everything that we do in this program. As I said yesterday in the group, nothing is arbitrary. Everything is to a plan. Everything is to a plan. There's a reason for everything that we do in this program. I've been doing this for maybe 30, 40 years. And over the years, I have evolved and I've discovered the things that improve and increase the chance of success in this subject. And I'm applying those things there. And people who follow those things to the T, they usually do so well. They make the Caribbean top 10 list, or they make the school top 10 list, or they make Jamaica top 10 list, and they get the ones with state aids comfortably once they work with the program. Some people come here on a Saturday, and it is as if they come here just to see how quickly they can leave. They come and the whole objective is finish quick and leave. And we have 4 papers to complete on a Saturday. 4. 2 paper 2s and 2 paper 1s. And people just trying to rush out a year and they don't have nothing to go home and do. Know them nothing to go do. But oftentimes when they finish and they come out here, the outside for an hour waiting on a drive. When they could be in the classroom doing another paper. After 1 hour, I see them outside stand up still. I say, I thought you're gone. Why how come you still out there? And you have 4 papers to do. I don't think it was a situation where I had to be telling 4th farmers, 5th farmers, 6th farmers things to me think would just be smart things to know for yourself. You're preparing for an exam that is in a couple of weeks. I need to start posting back that time. Much weeks you have left. Exam is now much, much closer than it was far away before. In terms of the time of this program, we are much closer to the exam now. Exam is in May, early May, and we're in April now. Do the maths on that. Basically at the middle of April right now, and exam is in early May, 1st week of May. So technically, you really come like you have about 4 weeks, 3 weeks to 4 weeks left for the exam. Come on, man, I have to get serious now. I have to get serious. I have to have an intensity and a purpose and be deliberate about what we're doing. Can't just be floating through and going through the motions as if it's still in September. Not in September anymore. Time to get serious, and I should not be the one to be telling you to get serious. You're all big children. I don't have any first farm and prep children in here. You know what is at stake. And you come to class because I know you want to do well in the exam. We have to do the things that is required for you to do well in the exam. And I'm showing you those things. I'm not saying go and figure it out yourself. I am showing you and guiding you on the things that will bring you success in the exam. We have to fall in line and do them and stop working against them. Otherwise, on exam day, you're going to struggle. You don't need to be struggling on exam day. Exam day cannot be a fun day for you. Enjoy yourself in the exam room. See the question, know to do them, get them right, and come out of the exam room smiling. That's what it's all about. The only thing is that you come out sad, you come out smiling. Who come to the same class. All right, enough of that. Come on, we have to get serious now, man. Exam is around the corner. Forget serious. I'm not doing the exam and I'm serious. And I'm not the one doing the exam. Oh, that makes sense. I'm not the one doing the exam. You are doing the exam. They come here on a Saturday, come prepared to work. You won't come to just rush off everything and to go back home to do nothing at all. All right, I'm going to do paper from number 1 all the way around to number 11. All right. As I do it, you do it yourself. And as I said, the key thing is any mistake you made, you want to redo those questions from start to finish. Redo the questions that you got wrong. Even if you get a part of a question wrong, don't do over the whole question. Because they don't know what portion of doing the question caused you to make that mistake. So you have to clear that early. So that does correct the mistake. Right? A lot of the time it's about doing over the entire question. So that if your chain of thought that caused you to get part 3 wrong was while you were doing part 1, at least you would have corrected that chain of thought. So better don't do over the whole question. And for never do the paper, uno go and do it. Or even after I do it now, go and do it. Because you have to do the exam, you have to do the question, the exam with yourself. All right, let's go. All right. So this is 2019 January. Tomorrow we're doing another paper. 5 o'clock. All right. So this one says evaluate these things, right? Evaluate that expression there and give our answer in standard form. So you can literally put this in the calculator, you know, and give the answer in standard form. You know. This is this expression plus this expression. Right? And you are free to use the calculator in number 1. All right. So calculator, let's put everything in there. That's what it gives me. So it's 3.8 times n squared plus 1.7 times n cubed. That gives me initially 2080. In standard form, I want the decimal point to be right here after the first non-zero digit. Right? But that's a big number. So you know the power is going to be 10 some positive number. When it's a big number. When it's a decimal number, it's going to be 10 to a negative power. You cannot use that as a guide sometimes. Right? So how do I get the decimal point here? Decimal point starts out at the end. When there's no decimal point show, it's at the end. I need to move it back 3 places there. To move it back 3 places, you can divide by 10 cube, or you can multiply by 10 to the minus 3. Either way you want to do. So, in order for me to move the decimal point and put it where I want, and some character will put this in standard form for you now. Some calculators will put this in standard form for you. Oh man, sorry. Right? So watch this now. I'm going to show the adjustment to move the decimal point. I can divide it by 10 cube to move the decimal point for me. But to balance out that division by 10 cube, I now have to multiply back by 10 cube. And so this calculation in here will move the decimal point for me. Then I can write the answer. The decimal point is now here, so it becomes 2.08. You do have to put that last zero. The last zero is immaterial after the decimal place. So I don't need that last zero. Times back this 10 cube. That is the answer in standard form. What good at that? What good? Some calculators will give you a standard form. See it here? This calculator give them in standard form. 2.08 times 10 cubed. So some calculators will give you a standard form. But I think PXC might want to see this kind of work to see how you adjust the number to get standard form. All right? Next question. They want us to work this out and give the answer the fraction in lowest terms. I'm going to put in the calculator again. And maybe they want you to work out the numerator first and then work out the diameter. I don't know, but I'm going to trust that I'm free to use the calculator. Because the paper says that you can use a calculator. Here is it. See there? Electronic calculators allowed. So the numeric calculations, you do them with a calculator. You get me? It's numeric. So just like this one did not say use a calculator. Most time it will say use a calculator, but this one didn't say. But I'm gonna assume it's the same thing. So I'm just gonna put this in the calculator and give the answer as a fraction in lowest term, which the calculator will do for you. So the fraction top there, we have a half. Zoom it up for you so you can see it. So I'm putting this in the calculator over here. So it's a half times 3/5 over, that's a mixed number. That's not 3 times a half, that's 3.5. So put the mixed number on the calculator. So don't try to construct 3.5. You put in the mixed number 3.5. So you press the mixed number button on the calculator, the ABC one. Oh, I'm it already. So it's 3.5. And see, I put in the calculator exactly what I want on the screen, on the paper. Half times 3/5 over 3.5. Your calculator give me decimal, but your calculator can also give it in fraction form. See it here? Right here. 3/35. So this equals 3/35. That is it. 3/35. All right. Next part says express. See it here? Just the binary number the other day. So I could paper here with it. Express 6 as a binary number. So just to the topic of binary numbers, of base numbers, and now we have to convert 6 to binary. Remember, we're using the place value approach to convert binary to decimal or decimal to binary. All right, so the place values for binary. Binary means base 2. Binary means base 2. So it's 2 to the 0, place values. It's 2 to the 0, 2 to the 1, 2 squared. 2 cube will be the next one. But we don't need to go up to 2 cube. But 2 cube is 8, and this number is just 6. They don't have to go any further. Those values are 1, 2, 4, and 6. So the idea is 2, 4, and 8. Sorry, 8. Those are the place values. So the idea is how do I use these numbers to make up this 6? That's what the idea is about. So I have 6, starting with a 6. Can use the 4 one time. And in binary, the beauty about binary is that you use these space values to make up the number either one time or no time at all. It's the beauty about binary. And the only values allowed in binary, 0 and 1. So the 0 is when you don't use the value. 1 is when you use the value. So we're going to use it the 4. So put a 1 to say that we're going to be using the 4. And then I subtract the 4 the time I'm using, so much I have left. I have 2 left. So out of this 2, I can use the 2. Can use the 2. So I'm going to use the 2 right here. When I use the 2, I have nothing left. So I'm not going to be using this one. I always fill out the place values with zeros when you don't use it. So I'm not going to be using that one. So it means that 6 to base 10 is equal to 110 to base 2. That's the answer right here. But go to that. But okay? Huh?
Yes, sir.
That's it. All right. That's it. All right. So we did a number of this. We did bigger numbers than this. When? Wednesday or Thursday. Thursday. All right. Let's this one says, and so when the CSEC set this binary question, it's the first time in about 30 years they set one. So they don't set this thing on exam paper. It's 1 mark for it. But the 1 mark. 1 mark can be the difference between a grade 1 and a grade 2. So 1 mark. Right? I want every mark. Next question says, John bought a car for $65,000. If the value of the car is depreciated, it's reduced by 8% each year. Now, if you take off 8%, you're going to have 92% of the value left back. Think of it that way. To reduce the calculation, just think. If you take off 8% of the value of something, you have 92% of it left. But understand that? Because you're taking off 8% for the 100% value that it was. So each year, the value is going to be 92% of what it was the year before. Make sense? 92%. It says, how much will the car be worth at the end of 2 years? So see it here now. So you start out at 65,000 at the beginning. End year 1, I can say year 1 end of year 1. That is, once you taking off 8%, so we have 92% left. 92% of the original amount of 65,000. But I don't even have to work that out. That is the value after year 1. I don't even have to work it out fully. The following year now, I'm going to do 92% of this. And this is the value now. But I don't even have to work out to show what the value is. Because I don't need me to show that. I can, for the year 2, I can do 92% of all of that now in year 2. So without working it out, we can say, okay, end of year 2 value. It is now 92% of this, which was 92% of 65,000. And put that in the calculator and get that. But after that, can you apply the 92% twice? But after that, how do we get the 90%? Okay, taking off 8%, right? So right, and put that a note up here so for how we get the 92%. So we say new value from this 8% depreciation means that new value equals 100 minus 8% of old value. That is 92% of the old value. And that's after 1 year. Each year it go down by 8%. So it's annual. So that's how we get the 92 that we have. Or some people will calculate 8%, subtract it. See what the new value is. They calculate 8% again and subtract it. It's too much work. Just know, say if you take off 8%, you have 90% left. You are interested in the value that is left. Right? Say, how much is it worth? What is the value of it after 2 years? So you're depreciating it by 8%. New value each year is 92% of what it was the previous year. Simple as that. All right? Very good. So if you wanted to work out this number and then do 90% of it, you could have done that as well. But you don't absolutely need it. All right? So that is it. Let's see what this works out to be. So it is 92%. I can put it in already now what this was if somebody chooses to work it out. So let's carry this down. Just write what it would have been if somebody decided to work it, to actually work it out. So if you want to actually work out the year 1 value, end of year 1 value to be 92% times 65,000. And it would have been, put it in red. It would have been, put it here, so. It would have been 59,800 if somebody decided to work it. And then here now they would have been doing the 90% of 58,000, um, 59,800. So here now you'll be doing it's 90% off 59,800. So you could have decided to use that figure if you want it. You want to know it, but you don't absolutely need it. You'll get the same answer. Right? If you do 92% of the 59,800, gonna get the same answer. I didn't know I thought right on the screen. So I'm gonna set it up. So 92% times 92% times 65,000. That is it. 55,016 is the value of the 2 years. 55,016. All right, Father God? Are you okay with that? All right, good. If you didn't get it, go and redo the question. Simple. Let's go and redo it. With pen to paper. He said the table below shows the results obtained by a student in her CSEC math exam. He said the maximum mark for each paper is given in the third column. This is almost like 2, That's all the paper mark for 2, Like 20 for paper 2, 30 for paper 1, and 20 for the SB. People choose the SB. But it's not quite straight line because they have a weighting system as well. And each type of question carry a different kind of weighting. You have knowledge-based question, you have calculation-based question, you have understanding type question. So that's all they set up the profile. So not all mark. 1 mark on a question carry different weighting depending on whether it's an understanding question, a knowledge question, or what. I'm gonna send all the mark the paper in the group one of these days so you can see. Or the apply the weighting. But anyway, so these are the percentages obtained, and these are the total marks that are available. It said determine as a percentage student final mark. The beauty about this is that everything is marked out of 100. So when you get the mark obtained for this, the mark obtained for that, mark obtained for that, it is out of 100 anyway. So all you have to do is work out these percentages and put them here. So these are the percentage obtained. We can put the mark obtained right here. So this is the maximum mark. We can put the mark obtained right here in a column by itself here. Just to give us something to write. This is the mark obtained. All right. And we cannot work them out. So it is 55% of 30 she get. And then we add them up. So she get 55% of 30 at 16.5. 16.5 marks. 60 don't give half marks either still, I don't think. As far as I know, they don't give half. Then she get 60%, 60% of 50. That's 30 marks. Then she got 80% of 20. 80% of 20. That's 16 marks. So she collected a total, the added up now, 15.5 plus 30 plus 16. So she got 62.5 marks. That's what she got. And that's out of 100. See that? So that's the percentage then, 62.5. So percentage obtained is 62.5. But I got, but I, so you don't have to do it exactly like this, but you want to know the marks that you actually got. And then that beauty about this is easy because it was a total of 100 marks. If the total was, for example, 120, you have to divide the marks you get by 120 and multiply by 100. But this was a nice 100 marks total anyway. I think this is exactly how CSEC do the papers. All right, next question. All right, let's continue. Number Number 2, make x the subject of this thing. Make x the subject. I have y over here. I have p over here, 3p. I want to make this x the subject. So I can transpose everything away from the x. So I'll take this 3p and carry it over first and subtract it. I want to transpose everything away from the x. So I'm going to get y minus 3p equals x over 5. Then I take this 5 and I multiply it up across that side. So I get 5 bracket y minus 3p equals x. That is x as the subject, i.e. that is x equals 5 into y minus 3p. If you want to expand this and put 5y minus 15p, so I put that, same thing. All right, but this I'm putting as my answer down. I'm leaving it factor. Let me shift this up. One or that, right? This one says solve this equation. It's a quadratic, you know, but it's not a trinomial quadratic. See? It's just 2 terms. They don't have to factorize, do long factorization. You cannot factorize out a common factor of x right there. So see that? Common factor is x. So it's factorized into the x. Then I have 2x minus 9 left in the bracket equals 0. It's not a quadratic with 3 terms. That would have given you the double bracket factorization. So 2 terms quadratic. So you factorize it easy like that. All right. And then if this times this equals 0, then either this x is equal to 0 or this 2x minus 9 equals 0. This x equals 0 is the solution. For this one, to get the x, you have to carry over the 9, make it positive 9, and then divide under the 2. So the x on this side would be 9 over 2. So your solution down here is x equals 0 right here, and x equals 9 over 2. Will be a solution. 2 values. Easy like that. All right, simple. Let's continue. Number 2b. He said the farmer wishes to enclose a rectangular plot with a wire fence. He said the width of the plot is 3 meters less than the length L. So the width is 3 meters less than the length L. So the best thing to do with this now is just sketch it out. So I would sketch out something and draw one rectangle like so. And put some dimensions on it. So I'm gonna let the length be L, the L right here. But the width is 3 meters less. So the width is L minus 3. That's the width. See that? And them say, given that the area enclosed is 378 square feet. No, square meter, sorry. So this is the area is 378 meters square. That's what I mean by square meter. It means that this times this, length times width, is equal to that. Right? So from this, it means that the length times the width is equal to that amount, 378. And you expand this. Expand this, you get L squared minus 3L equals 378. And this now the 378 on the left side. So let's take this 378 and bring it over here and subtract. So you get L squared minus 3L minus 378 equals 0. So we have shown that equation. They don't want us to solve it, no show. Show. Just show it. So it's all shown. You have shown it. You don't need to solve it. Just show it. Work it out and get it on that. Alright? Alright. Let me put area equals in this instead. Right. Area equals. 378. That's our rectangle. Next part. So variations. So the force F applied to an object is directly proportional. Directly means K times to the extension E. The extension E produced by that object. So like an elastic. You put a force on an elastic, it's going to extend. The extension is directly proportional to the force, and the force is directly proportional to the extension. That simply means that the force is equal to a constant times E. Simple as that, because it's direct. If it was an inverse variation, like with a spring and squeezing a spring, then the force would be K over E. It wouldn't be an expression, but like a depression. If it was inverse, this is what it would be. But it's a direct, so it's K times. Just read it carefully. The force F is directly proportional, which means K times the extension E. The extension E. That's the formula right here. Simple as that. F equals KE. Put it down there, sir. F equals KE. F equals KE. Now, this question is not asking us for the K. It's asking us to find the X and the Y in the table. Now, this value, that pair of value, that pair of value could be used to find K. But the question is not asking us for a K. And when those ask for a K, you can use a method of solving it without finding the K. Just get an expression for what the K will be equal to, like this. So this is it. Based on this up here, let's put it in verb. We divide by the E, F over the E would be equal to K. So it means that the force over the extension is a constant at all times. The force over the extension is the same constant at all times. And we can use that as a premise too. We don't have to calculate the K. You can calculate the K by plugging these values up here, so you know, I work out the K. But I still want to show you how to do it without finding the K. I don't need to find the K. So when you use that method, the K is equal to this. See here, don't understand. I want to find this. So I know that the K is always the force over the extension. This is what I'm going to be using. So it means that pair here, F and E, it means that force here over that E there is equal to the force here over that E there. That's what it means. All right? You see it here now? This force, 25, over this E, X, is equal to any other pair that you know. Is equal to this force, 8, over this E, 0.2. Well, it's actually X. Right, X for it. I know you're trying to find the X. To find this X, I can take this X, multiply it up here, and then take this 0.2, multiply it up here, and take this 8 and divide it down here. So look at this transposition now. So I can get X equals 25 times 0.2 over 8. Everyone say that. You can say that. What I say that? Cross multiply. So I take this X and I multiply it up here. That's what it ends up here. So. And I take the 0.2 and multiply it up here. That's what it ends up here. So. I take this 8 and I divide it under here. That's what it ends up under here. And so X will be equal to this calculation. Okay? So X equals whatever this is. Let's do the other pair now for the Y. Other pair for the Y. Same thing again. The force over the extension is a constant for any pair. So this force of Y over this extension of 3.2 is equal to this force of 8 over this extension of 0.2. That, if you want to work it out by finding the K, you might guess. But I'm showing you can actually do it without finding the K. But get what the expression of a K is. And what this is saying that the force of an extension is a constant value. So in every pair, the force of an extension is the same. Similar to sine rule. The force of an extension for one pair equal force of an extension for another pair equal force of extension for another pair equal force of extension for another pair. For any pair, the force of an extension is the same. Right? So this force over this extension here, so equal this force over this extension here, so. And I'm set up an equation and solve it for the x. Cross multiply. We're ready to find the y now. The y is a force. So this force over this extension, see there? Force over the extension is equal to this force over this extension. Or if I wanted, I could use this force over this extension. Because they give you two pairs of values that you actually know that you can use. So to find this y now, we're going to take this 3.2 and just multiply it up here. So we're going to get y equals 8 times 3.2 over 0.2. I'm going to get what the y is down here. I'm done. Let's get the calculator and work out these now. So the first one is this fraction. It's a fraction of 25 times 0.2 over 8. That gives me 0.625. That's x. And for this one, I'm going to do this calculation. I'll clear the calculator again. There's a fraction 8 times 3.2 over 0.2. That's 128. And those are my answers. Simple as that. K is of F over E. E over F is a constant too, you know. If you take the reciprocal of K, you get 1 over K, so that's a constant. But all this work with constant is F over E. F over E is the same for all the pairs of values. Set up like that. Just stand up. It's being recorded, so you can watch over the first one, right? All right, question done. Number 3, that's a construction question now. What did I say? Sketch it before you construct it. Sketch it before you construct it. It says, using a ruler, a pencil, and a pair of compasses, construct a right-angle triangle in which AB is 5, the angle at B, the angle ABC is 90, and the angle at A is 60. Let's sketch it. And then we'll construct it. So this is it. So AB must be 5, so it's going to be 5 centimeters. The angle at A, make this be AB. The angle at A must be 90 degrees. The angle at B, sir, must be 90 degrees. So we're going to put 90 degrees over here. Here, so it's going to be 90, and the C is going to be up here. And then the angle at A must be 60 degrees right here. So here it's going to be 60 degrees. That's what we're constructing. So we're constructing 90 over here, so, and construct the 60 there, so. Let's go and construct it. All right, let's construct it. Let's go and construct it. Where's my construction thing? Here you go. Hold on. All right. So I'm going to construct it right here. All right, I'm constructing this thing over here. All right, so ruler first. I'm going to draw a line of 5 centimeters to begin. 5 centimeters. Let me shift this over. So 5 centimeters. 0. That's not right. 0 out of 5 is 5 centimeters. It's 5 centimeters. Then I need to construct 60-degree angle at the point A. Let's get the compass. And come to this end. Adjust it to a reasonable length. Lock it. 60 degrees is the easiest angle to draw. Only 2 arcs needed for 60 degrees. So make an arc that's about 60 degrees up here. So move the point to here. We make cross first. Rotate. and cross that one. So you know 60 degrees will pass through that. We draw a line through there 60 degrees. I'm going to construct the 90 same time over this end. So over here I'm going to construct the 90. So remember now to construct 90, our method is to construct a 60 and a 60 and bisect the second 60. That's how we do it in this graph. We construct a 120 arc and bisect the second. So we divide the 120 to 60, 60, bisect the second 60. We're going to make a long arc first. Long arc all the way around here. Come to this point and make that first cross at 60. Come up to this point and make that second arc. It's a second 60. So I need to bisect the 60 on top here now. One on top here, I need to bisect it. So come to this end of that 60-degree arc, rotate up here and make an arc at the top above it. You come over to this end, rotate over again, and cross that one. I'm ready to draw my line. I'm going to draw those two lines in black again. All right. Now, firstly, I'm going to draw this one all the way up here, the 90. Let me draw the 90 first. Right through the intersection, 90. All the way up here. And then I draw through the intersection, like you're going off the screen. Through the intersection and stretch it right out. So it's supposed to go all the way up the top here. So like the first line need to go further out. I don't want it to join it, but it's joining it. I'm gonna take this off. Just add it down. So this need to go all the way up here. It needs to join, but it not. Let me do that more. Should have joined this thing further down. So I'm gonna extend this all the way up to the top, the 90 from now. I'm gonna extend the 90 all the way up to the top. All the way up here. And I'm gonna put in the 60 to join it. Nope. That's it. So it means that I'm putting in the points now. Right here is A, right here is B, where the two lines meet up here is C. That is my C. And then the angles now. This angle inside here, 60 degrees. And this is 90 degrees. And this is 5 centimeters. That's a construction. That's a construction. All right, I'm gonna copy this and see if I can bring it over here. See if I can copy it over here. All right, so that's a construction. All right, that is I want us to do. Right, and it. Okay, all right. Good. That's a construction right here. 4 marks for doing. Anything else? Just construct and make up. That's it. So you sketch it and then you construct it. All right, guys? sketch it, and then you construct it. Let's give us a sketch first. This is it. All right, next question. It's supposed to do this. So question gives us that right angle triangle. So now in a right angle triangle, you can use so-called tower, and you can also use Pythagoras theorem. To this angle, this should be the opposite side, and this should be the adjacent side. This is be a hypotenuse. Hypotenuse is side opposite the 90 degrees. That's the 90 degrees. All right? I'm talking about this angle is an angle under consideration. Says using the diagram, express C in terms of A and B. That's Pythagoras theorem. So Pythagoras theorem is what connects the three sides in a right angle triangle, right? So they want an expression for C in terms of A and B. So that's a hypotenuse squared is equal to the sum of the square of the other two sides. A squared plus B squared. But it's because them say C, you take off the square of this and square root both sides. All right, C equals square root of A squared plus B squared. For the simple reason that let's say C, this is C squared, right? But it comes from Pythagoras theorem here as a first. But good. Next part now says, write in terms of A, B, and C an expression for sine theta plus cos theta. Right? Sine theta plus cos theta. So let's look at it. Sine theta plus cos theta, what? So sine of theta plus cos of theta, shift it over, is going to be equal to, now the sine of theta is opposite over hypotenuse, don't it? So it's going to be opposite over hypotenuse plus cos of theta is going to be adjacent over hypotenuse, adjacent over hypotenuse. So the opposite is A and the hypotenuse is C, don't it? It's A over C. So this is A over C plus the adjacent is B and the hypotenuse is still C, don't it? Adjacent over the hypotenuse becomes B over C. So this is B over C. Because the two of them have the same denominator, we can just add the numerator and put it as A plus B over C. Put everything as A plus B over C. That's what sine theta plus cos theta is equal. But I get that? Sine theta plus cos theta is A plus B over C. All right. Down here now. It says, using the results from A and B in part 1, show that sine theta squared plus cos theta squared is equal to 1. Sine theta squared plus cos theta squared is equal to 1. So we have to work this out and show say it equal to 1. That's what they want us to do. All right? So we're going to start by saying, all right, the sine of theta squared plus the cos of theta squared is initially equal to, what is the sine of theta again? Sine of theta was A over C, don't it? So it is A over C squared plus cos theta is B over C, so it is B over C squared. But I hear that. Good? Then this becomes A squared over C squared plus B squared over C squared. That's all. Which then becomes, common denominator becomes A squared plus B squared over C squared, don't it? But remember from over here, the A squared plus B squared is C squared. Or you can say the C squared is A squared plus B squared. Anyway, you want to look at it. So you can say, okay, so that C squared there is A squared plus B squared. Or instead of A squared plus B squared there, it is C squared. All right? So remember now, from part 1, the c squared was equal to a squared plus b squared. So we can replace that a squared plus b squared with c squared. So it's become c squared over c squared. C squared over c squared is equal to 1. So I've shown that this thing equals 1. What is that? Right? I.e., that is sine theta squared plus cos theta squared is actually equal to 1. If you wanted to put this as the a squared plus b squared, the a squared plus b squared over a squared plus b squared will come 1 anyway. Understand? That is it. So this is shown. That is it. But all right, I worked over again necessary. Right? So that's all on the part of the theorem so far taught is what we call trig identity. When I was in school, this is something that we had to know and use for CSEC. Sine squared plus cos squared equals 1. Right? Have to know that. Use it. But anyway, let's go down to number 4. So number 4 gives us that function. It's a rational function, like a fraction. A function on top and a function and a day. So it's a function divided by another function. Call it a rational function. It said, say the value of x for which the function is undefined. Remember, it is undefined when the denominator equals 0, don't it? Remember that? But you can't divide by 0. So that function is undefined. Undefined means that you can't get no real value from it. Can't work out. That happens when the denominator is 0. Right? So f of x is undefined when the denominator, the 5 minus x, becomes equal to 0. That is when the x becomes equal to 5. Fine. About that 5 will make that function undefined. It means that 5 cannot be in the domain of this function because it can't work out. When x equals 5, this thing can't work out. You want to try it? 2 times 5 plus 3 over 5 minus 5. I'm going to give you some syntax error on the calculator. So when the x is 5, this function has no value. It cannot work out. Okay, you cannot divide by 0, guys. You cannot divide by 0. This becomes a 0. You cannot divide by 0. It becomes 13 over 0, which cannot be worked out. If you try this on the calculator, it doesn't work out. See here? 13 over 0. If I use that on the calculator and put 13 over 0, you get some error message. See? Division by 0 error. Can't work out. So the function is not defined when x equals 5. Because 5 is going to cause you to be divided by 0. Right? That is it. So x equals 5. This is something we do with this function. But remember we did this in functions. And I said what was one of the rare things that they said. When a function is undefined, the denominator, the value of x that will make the denominator 0. So we can say something like this. X cannot be in, not x, 5. X equals 5. Not x. X equals 5. This 5 cannot be in the domain. X equals 5 cannot be in the domain of f of x. You answer the question that way that you know. You answer, what value of x cannot be in the domain? 5 can't be in the domain. Because what it means that when x equals 5, it won't have anything to map onto. What did we say a function was? We say a relation is a function when each element in the domain map to one and only one element in the range. So if you have a 5 in the domain, there's no value that 5 can map onto another this function. Not f of x in it, h of x. H. I put f, but it's actually h. Right? So The point is, if x was in your domain, it wouldn't have any value mapping onto. Because see, when you put 5 in this function, it would work out to infinity. It don't work out to nothing. So 5 in the domain would not be mapping. And we did say you cannot have any element in the domain that is not mapping. Remember we said that? And also we cannot have any element in the domain that is mapping to more than one value. You cannot have a one-to-many. For one-to-many mapping, it's not a function. Remember that? We did that when we did function, guys. Right? You have to remember the things. That's why we have to revise and work these things over again. So 5 cannot be in the domain because it would not be mapping to anything. It would be a free element in the domain, not mapping to anything, and you would not have a function. 8 would not be a function if x was equal to 5. So 5 cannot be in the domain. So this function, 8, this function can only work if 5 is not in the domain. It can only become a function and operate and work if 5 is not in the domain. So 5 cannot be in the domain of this function. Because then it can't work. It would not be a function. Because 5 would not be mapping to any value. It cannot have any value in the domain that is not mapping if it is going to be a function. All right? This one wants us to find h to the minus 1. So we're going to start with h equals, same thing up here, 2x plus 3 over 5 minus x. 2x plus 3 over 5 minus x. And then we'll go through the same process of inversing this thing now. Same steps. Start this way. H equals that. I'm going to inverse it. Inverse it. When we inverse it, the h, which is range, becomes domain in the inverse. And the x here and here, each becomes h to the minus 1. Range in inverse. So we'll get 2 times h to the minus 1 plus 3 over 5 minus h to the minus 1. Some teachers would have put y here, so and call the function y, but it's the same difference. Not doing anything different. And some teachers call it x and y, interchange x and y, transpose make y the subject, and that's the inverse function. Same thing. Anyway, to it, we still have to go through that process of transposing this to make the h a subject. I want to make this h a subject now. We're going to expand out everything into separate terms. I don't want the h to be dividing by itself here, in a sense. So if I expand out everything into separate terms, group everything with h to the minus 1 on one side, so you can factorize it and divide away the factor. That is the steps in this process all the time. So the first thing is to expand it out into separate terms. How do I expand this out into separate terms? By taking this denominator and multiplying it across there. That's the first step. Take the whole denominator and bracket up for you. Take the whole denominator and multiply it across here by the x. To expand it out into separate terms. That's the first step all the time. So it becomes x times the 5, which is 5x, and x times the h to the minus 1, or minus h to the minus 1. So you get minus h to the minus 1x. I can put x in front, it don't matter. Minus x, h to the minus 1, same thing. Equals, this stays on the right side. 2h to the minus 1 plus 3. Then I need to group these two terms on the same side. I can group them over here if I want, or I can group them over this side. Now, because this is negative, I'm going to carry it over here to become positive. I'm going to group my h to the minus 1 on the right side this time. It means then, I'm going to take this negative term and bring it over here and turn it into positive. And I don't want this 3 away. I'm going to take this 3 and bring it over here and change it to negative. So I'm going to get this 5x minus 3. We care about the 3 becomes minus 3. Equals 2h to the minus 1. This stays where it is. I'm not moving it. Take this and bring it over here. It becomes a plus. So I get plus x h to the minus 1. But I understand that's a part. So I took this 3 and bring it over here. It becomes minus 3. And I took this minus xh and bring it over here. Becomes plus xh to the minus 1. Then to factorize the h to the minus 1 of these two terms now. So I'm going to get h to the minus 1 into 2 plus x. Now factorize the h to the minus 1 over those two terms. I get h plus 2 plus x in the bracket equals 5x minus 3. Then to leave this h to the minus 1 as a subject, I just take this now and divide it on this side. And that leaves me with h to the minus 1 as the subject. So I'm going to get 5x minus 3 over 2 plus x equals h to the minus 1. That is my h to the minus 1 of x. You have to practice this transposition, guys. 3 marks for it. So you can write i.e. that is, let's put this on the left side, i.e. h to the minus 1 equals 5x minus 3 over 2 plus x. That's my h to the minus 1 of x. I'm putting back the of x now. That's h to the minus 1 of x. That is the inverse. That's my answer down here. So. But all right, you have to practice position. Did do all of this already, you know, from last year, for December. It's practice. All right, let's continue. Then we have this line on a graph. Always nice to get line on a graph. Okay, you can see the y-axis intercept, like for example here, and you can choose 2 points and count out the gradient, like here and here. So it's a negative gradient, rise negative, whatever that is, run, whatever that is. So it's always nice when you get a line on a graph. You can see the gradient, count it off, you can see the y-axis intercept. Let's make sure we have these coordinates though. So this is 0 to 2. So right here says 1. Right here says 3. Right here says 4. And right here says 5. Make sure we have everything. Right here says 5. Right here says 1. All right, here says 3. All right. Let's see what the question says. The graph below shows a straight line. So a straight line intersecting the x and the y-axis, right? It says use the graph to determine the gradient. I don't have to calculate. No. Just count the rise and count the run from the point here to that point here. What is the rise and what is the run? I just need the run and the rise. All right? I can do the rise first and then the run. Or I can do the run first and then the rise. It don't make a difference. Let's do it that way. Let's do the run and then the rise. But I don't want to come and complicate this area. So I'm going to show what the run is first. So I'm going to run across to here. That is my run. How many units is that? 1, 2, 3, 4, 5 units. Then I'm going to rise down to here. That's a negative rise because I went down. 1, 2, 3, 4 units. So my gradient is rise over run. Word rise and rise. My gradient is rise over run. So the gradient M is rise over run between any 2 points. The rise is -4, the run is 5. That is the answer, right? Easy. And you know, calculation. Some people put on points and I calculate and I do different in whatever different things. Waste of time. When you have the graph, you can count off your rise and count off your run. Just find 2 points. You can actually count the coordinates. That's all you need. So use those 2 points. Couldn't use any point in here because I couldn't see any exact coordinates. You see that? I couldn't see any other point along the line that I could see. Coordinates. I like to use points to pass through the grids like these. So you can actually get the exact coordinates. I don't want to use any point here, so you have to be estimating. No, I don't want to get into that. That's why you make mistakes and put on the wrong thing. You use 2 points, you can count the coordinates properly. That's the rise. That's a gradient. Next part, the equation. The equation is y equals mx plus c. What is the c? The c is right here. C is 4. See it here, so? Y-axis intercept. C equals 4. It's there on the graph. You don't have to calculate nothing. So the gradient is this, and the c is 4. So let's write it up. Y equals mx plus c. The gradient is -4/5. And the c is equal to 4. put them in here, son. So the equation is y equals minus 4 over 5 times this x plus this 4, the c. That's the answer. And then your calculation, straightforward. And everything is on the graph. Next thing was the equation of the perpendicular line passing through P. What's coordinates of P? P is a point 5, 0. Remember? P is right here on the x-axis. 5, 0. The one the perpendicular line passing through C. So I'm going to show you the line that I want. I'm going to write it purple for you. The one the line was perpendicular to this. It's supposed to go like so. Something like this I want. Perpendicular to this one. Right? That's what they want. When they want to calculate it. So you need to find a gradient. You need to find a gradient. So watch this now. The gradient of the original line is minus 4 over 5. That's the gradient of line 1. Gradient of line 1 is minus 4 over 5. What's the gradient of line 2, the perpendicular line? What's the perpendicular gradient? Flip this and change the sign, don't it? It becomes 5 over 4. That's all? 5 over 4. So 5 over 4 will be rise 5, run 4. So starting from this point on the line that I want, I put rise 5, run 4. I put it in purple and show you where it pass through. Rise 5, 1, 2, 3, 4, 5, run 4. 1, 2, 3, 4. So the line that we want pass through here. I'm just showing you. Line that we want pass through there. So the line that we want is this one. I don't quite try, but you get the picture. The line that we want is that one. That's the line that I want. It's perpendicular, don't you? So. But this is the point P. That's the point P. So that's the line. That's line 2. I'm just doing this extra work. You don't need to be doing this. I'm just doing some extra work. All we know is that the gradient of the line I want is this. And the pass to the point P, which is 5, 0, right? So P is the point 5, 0. Let's go down here. So this is all you need to do. So the line that you want is perpendicular to the first line. So the gradient of the perpendicular line is minus 1 over the gradient of the line that you have. Let's call it line 1. The gradient of line 1 is minus 4 over 5 that was calculated. So this perpendicular gradient is flip this and change the sign. It becomes 5 over 4. So line that we want has this gradient passing through this point. So we can have the BFF. So the equation of that line is y minus the y value of the point equals the gradient of line 2, the perpendicular gradient, into x minus the x value at the point. It's always good to use this to find the equation of a line. Some people would use y equals mx plus c, and then use this point to find the c, no problem. That's fine. But this one gives the equation straight off the bat. So it becomes y minus the y value at the point is 0 equal the perpendicular gradient is 5 over 4 into x minus the x value at the point is 5 right here. Since this is a 0, I'm just going to expand this 5 over 4 across this bracket and put y equals 5 over 4 times x and then this time this becomes negative 25 over 4 minus 25 over 4. That is the answer. But I just showed you on the graph. I didn't need the graph to do it. I just need that gradient and that point to get the equation. Remember, to find the equation of a line, you need to know 2 things about it. You need a gradient and a point. You need a gradient and a point. Don't put the 1 on this. Gradient of line 1. Gradient of line 1. First line. All right. Put up here as well. Gradient of line 1. Print off line 1. I'll introduce a second, but that will be the second line, the purple line 2. Will be the second. That's its calculation. Done. All right. Let's go on. Next question. Number 5. Number 5 says, a survey was conducted among 48 students to find out what mobile phone or what mobile network they use. The table below shows the results of the survey. So it's 48 students. This is supposed out of the 48. Does it? 20 and 10. Yeah, 48. All right. It says, if this information is to be represented on a pie chart, what is the angle of the sector to represent the O phone right here? What will be those angles? So the total is 48, right? The total is 48. And you want the angle for each sector. So the angle for each sector would be the value divided by the total multiplied by 360, because the total angle in the pie chart is 350. You agree? But I hear that? So the angle here for O phone, so the O phone angle would be 10 out of 48 times the total angle, which is 360. I wrote that out. That would be the O phone angle. Circuit out here. So that would be 10 over 48 times 360. That would be 3,000 something, 75 degrees. That would be 75 degrees, right? 75 degrees. So it should be 75 degrees right here. 75 degrees. Put percent, 75 degrees, Mr. Shaw. Now, if 10 people is 75 degrees, then 20 people must be twice as much, don't it? Make sense? Don't it? So it should be 150 degrees. Guys, it's 2 times 75. Put it in bracket for you. God, it should be 2 times 75. 2 times 75 degrees. Then what will be this one? So we're going to need all them in the question asks to complete this pie chart. So you have to get all the angles. So this one, the others would be 6 out of things. Let's work it out here, sir. This is the answer for O4 right now. Let's just work out others now. Others. Angle would be 6 out of 48 times 360 degrees. That would be the other angle. So let's work it out up here. 6 over 48. 6 over 48 times 360. That will be 45 degrees. That will be 45 degrees. So this angle will be 45 degrees. They didn't ask us for it, but we need it. Let's leave it in there. It should be 45 degrees. And since it's at 12, it will be 2 times 45, don't it? Don't it? If 6 is 45, then 12 must be 2 times 45, don't it? It's 90, right? It should be 90 degrees, which is 2 times 45 degrees. So those are the angles. And question wants us to complete this pie chart. Did use the circle below with radius shown, represent information in the table, clearly labeled pie chart. So I want us to do a pie. I'm going to construct it over here for you. But we're going to do the I'm gonna do it with the with the protractor. So let me move this over here and draw it for you. Circle first. I'll put a line that they have open up a little bit like this. That's how it looks. I'll put in the angles now for each sector, right? So let's put in the wire tech first, which is 150. Let's put them in here. So measure the angle at the center here, right? So we're gonna put in a 150 degree first. Let's say we're measuring them around this way. So we're measuring them around this way. All right? Which it doesn't matter. You decide which way you go. So first angle I need is 150. I need it from this line that I just draw. So I need to put it through 0. So pass through 0. In the inner scale, which is the 0 scale. So I'm going out to 150. So where do you know? You put on a little mark at 150. So 150 is all the way over here. So I put a little dot. 150. Then I can move that out the way and draw a line. As if I'm going out to the dot. See that? I'm actually coming to here. That's 150 degrees right now. So inside here, so the first one, wire tech, double tech. Let's call it double tech for now. Let's go again. All right, double tech. All right, now give me the C. So double tech is 150 degrees. All right. Then I need 90 degrees from that line. So bring back this protractor and I rotate around. This time pass through 0 and I measure 90 degrees. The 90 degrees is right up here. So I put like a dot. It's doing 90 degrees. And gone again. But that out. Put back this line. So I'm drawing this line down here for 90 degrees. Down to there, but I'm going to stop it there. That's 90 degrees. It's 90 degrees right here. That one is for digilect. Let's call it DL for DLect. DLect. 90 degrees. The next one I want is a 75 degrees. I want 75 degrees now. 75 degrees from that line. So bring back the protractor. Rotate one to 0. And I measure the 75 degrees on the 0 scale, which is the one that starts, the inner one is 75 degrees. So I put a little black out here at the 75 degree mark. But I can see that little dot. Right? At the 75 degree mark, then I draw the line out there. Wrong line. Sure. We draw them back again. Oh, that's this one out to here. This one down to here. And I bring this one now. So this is 75 degrees inside here. So this remaining is 45 degrees. The last one is 45. And this one was for others. Or other. And down here, so it was 04. And that is it. All right, so you can get this. And that is your thing. See me can copy it. It's supposed to look something like that. And you're done. All right. That is it. Next part now says, the incomplete table below shows the result obtained by 200 boys and 250 girls in a Spanish exam. All right, so these are the results, the 200 boys, the 250 girls. All right, it said a girl is chosen at random. So it means that you're working only with the 250 girls. A girl is chosen at random. During probability that she achieve a grade 1. See grade 1 here? That's 62 out of 250. But you have to come out of the girls, only out of the girls. Consider it from a girl. So that's 62 out of 250. That's what you want. 62 out of 250. If you put that as a fraction and reduce it, 62 out of 250 as a fraction reduces to 31 over 125. That equals 31 over 125. But I go to that, that is a selection from the girls. That is a selection from the girls. Next question says, what percentage of the boys who took the exam got grade 3, between grade 1 to 3? Let's look at it. So it showed us how many persons got grade 3 and 4 of the 200, which is 38. So it means that from grade 1 to 3 up here, so is 200 minus 30, don't it? Combined, don't it? That combined total becomes 200 minus 38. How many is that? That's 162. So it's 162 persons got between grade 1 and 3 out of the 200. That's probability. And the percentage of what? Percentage. What percentage? So that becomes 162 out of 200 multiplied by 100%. What is that? 81? 162. %. Right? So you have to work out how many persons got between 1 and 3. I could see it here. I didn't give you, so the total is 238 got grade 4 and 5. So the rest of them is 162 got between grade 1 and 3, which is 162. So the percentage of the 162 they wanted, which becomes that calculation. All right, next part says, considering the standard deviation in the table, compare the performance of the boys with the girls. So see the standard deviation here, girls and the boys. So the boys have a higher standard deviation, that's a higher value compared to a lower value. So the one with a higher value have a wider spread from the mean. The one with the lower value have a closer spread from the mean. Simple as that. The one with the higher standard deviation means that the grades of the boys spread out more from the mean and the grades of the girls. But the girls have a lower standard deviation, means that their grades spread out less from the mean. So these are more widely spread, these are more closely spread. So you can use terms for this one as more widely spread, more widely spread. These are more closely spread. This is in compared to each other, more closely spread. That's what happens. So let's write a statement to that effect. So if we can, either you're going to use the boys as the reference, I'm going to use the girls as the reference. Let's use the boys as the reference. Who have a more widely spread grades compared to boys, to the girls. And it's from the mean. Remember, it's from the mean. Standard deviation is measuring spread from the mean grade. So if we write that, so let's write something down here. So we're going to say the grades of the boys is only one mark for it. So we want to get it right still. The grades of the boys is more widely spread, like a higher standard deviation, right? From their mean grade. See? It's always from their mean grade as compared to the grades of the girls. If you're writing with a reference on the girls, there's an or. If you're using the girls as the reference, you would say the grades of the girls grades are grades of the boys. Grades of the girls are more closely, and not wide, no, closely spread from their mean grade. As compared to the grades of the boys. So whichever one you choose to write together. So this one is using the boys' grades as the reference. This one is using the girls' grades as the reference. All right. So down here, so the standard deviation for the boys was 8.2. Is a higher value. It's for the boys. The standard deviation. That's what the symbol for standard deviation of the girls was what, 6 point something. It's 8.2 and 6.3. 6.3. So the higher the standard deviation is, the more widely spread the values are from the mean. You have to say from the mean. This is very important. From the mean grade. Standard deviation is measured spread from the mean grade. All right, that's it. Next question. Number 6. Number 6 says, give us a diagram. Number 6 gives us a diagram, not drawn the scale, show the open cylindrical container. The open container, cylindrical container made of metal with a circular base and uniform thickness throughout. It's everything they put in bowl, ever pay attention to it. First, it's not drawn to scale. So you can't put any measuring device on it. I can't go by how anything looks. But it has uniform thickness throughout, and I put that in bold. So everywhere the thickness of the materials is consistent, right? Uniform thickness. He said the length of the container from the top to the bottom is 120. See here, so 120 from top to bottom, it's 120. It's open. That means that the bottom is closed. The container is a closed thing. But the top is open. So up here, so it's open. Down here is closed. Just visualize and make it be a real life situation thing. When you make these things real life, it makes sense. So if it is closed with material of the same thickness. Because it is uniform thickness throughout. So the same thickness on the side and on the top, the same thickness close the bottom. Because it is uniform thickness throughout. That's what it says. So the length of a container is 120, and it says the inner and outer radii are 14 and 15 respectively. The inner and outer radii. Let's put them on. They didn't show us those. Let me put them on here. So the inner radius, that's from center to here, is 14. Let's put the pen on the container for that. 14 centimeters right here. 14, Mr. Shaw. This is 14 centimeters. And the outer radius to here, that is 15 centimeters. 15 centimeters is outer radius. What does that mean? It means that the thickness of the material is 1 centimeter, don't it? Don't it? That's all. It means that this is 1 centimeter thick. One centimeter thickness. Gotta say the same thickness throughout. That's 1 centimeter thickness. All right? All right, good stuff. It's going to need to be calibrated. One centimeter thickness, that is. All right? Now, what that means as well is that down here is also 1 centimeter thickness, don't it? That's all. Means that down here is also 1 centimeter thickness, down here, so. It's also 1 centimeter thickness, 1 centimeter in thickness. Has 1 centimeter thickness show, 1 centimeter. So if over here says 1 centimeter, over here as well is 1 centimeter. Then it means that the inner depth of the container inside here says 19. The inner depth of the container to here is 190. The overall is 120. So the inner depth of the container to the top is 119. 119 centimeter. But can I appreciate that? Good. That 1 centimeter thickness throughout. This tells you what that thickness is right there. So down here says 1 centimeter thick. So the overall height is 120. Then internally it is 119. You subtract the 1. You get the inner depth of that container. It says now, draw the cross section of the container showing the measurements of the inner and outer radius. So the cross section is a circle. Cross section is a circle. So just kind of draw 2 circles with the same center, concentric circles, with the same center. And one is 14 and one is 15. So just draw one circle. You can copy that circle and make it bigger. You can do it with a device, but we don't have to copy, we don't have to draw it. Copy and paste. Push over it and just make it bigger. It must have the same center. Something like that. We have the same center. See that? And then put on the dimensions on it. So I want to make this be 14 centimeters out here. my center, and make this be 15 centimeters out of here. Something like that, and you're good to go. I like the center. Put where the center would have. Put a better center. Center is more there, so. So let's go again. So from here to here, and from here to there, I'm going to use those. So that's my center. This is 14 centimeters. This is 15 centimeters. That's my cross section. Concentric circle. What else am I? That's a section like up here. So the end is the cross section. Cross it. That's what you're gonna get. Everywhere across it. Same shape you're gonna get. So you can just do the dimension of the ends of the end, and that's it. And you show it like that. But I go to that. And then this would be the material. Around here will be the material. Around here, it basically be the material. That this is shaded. That will kind of be a material. Something like that. All right? That's it. Next question. Show that the capacity of a container is this amount. Capacity is the volume to full space internally, don't it? That's all? So talking about the internal dimensions. All right? So we're using a radius of 14 centimeters and a height of 119 centimeters. That's how we use it. I was in the volume of a cylinder. The capacity is the volume of a cylinder, pi r squared h. So the capacity equals internal volume or internal space. And that's a cylinder. With this radius and this height internally. So it becomes pi r squared h, which becomes pi, the radius is 14 squared, and the height is 119. I'll show you the calculation I get this. Sure, 73,304 centimeters cube. Let's do it. That's what we're gonna get. Let's do it over here. So we're gonna get the calculator here. We're gonna get pi, use the pi in the calculator, times 14 squared times 119. See there? 73, what I'm saying, 73,304. All right. Now I get 73,304. Did they tell us a pi to use? Let's see, they told us a pi to use. That is the difference. Huh? All right, so that is why. So they told us 22/7. I didn't use 22/7. So I'm not going to use it here, so now. 22/7. So it's 22/7. Check this over. So if you use their pi, I get the right answer now. So let's change this pi to 22/7. There you go. 73,304. Same Q. All right, shown. Done. Very good. What's up? There you go. Where is it? Oh, okay. All right. It says now, determine the volume of material used to make the container. So look at it now, guys. The volume of the material, the shaded part, is the outer volume minus the space inside. Give it the volume of material. Well, can I appreciate that? The outer volume of everything, and then subtract the volume of the capacity, the space inside. the container space inside. So it becomes the outer volume minus the inner volume, in a sense, right? Outer volume minus inner volume. Where the inner volume is this, you know. So it becomes the outer volume. So see, you know, volume of material equals volume outer minus volume inner. Inner volume. Where the inner volume is this figure up here. So now the outer volume becomes pi r squared h again, but using the outer dimensions now. Right? So when I use pi, let's use capital R. Pi r squared, and use capital H for the overall height. Capital H. That's what we're using. Minus the inner volume is this. So subtract 73304. Let's write the big H and the big R. So the big H and the big R are the outer dimensions. So the big R, remember, is 15 centimeters, and the big H is 120 centimeters. All right? That's what we're using. The outer dimensions. All right? Down here, we use the inner dimensions of one. All right? So we'll put them on this diagram up here as well. So up here, when I say small r is 14 centimeters, big R is 15 centimeters, small h is 119 centimeters, and big H is 120 centimeters. So the small one is for the inner, and the big one is for the outer. All right? That's what we basically say. So they're going to be this calculation now. So it's going to be same calculation here. The pi is 22 was the radius is now 15 squared, and the height is 120. 120 is 73304. Let's calculate. So it becomes 22 over 7. Show the calculation here. So 20 over 7. I am squared. And I multiply that by 120 and subtract 73304. So we're getting 115. Let's put to the nearest whole number. 11553 centimeters cubed. The volume of the outer material, outer container. All right, 0.1. So we'll leave out the 0.1. So that is that. What else they want us to do now? It says, given that the density of the material is this, 2.2 kilograms per cm cube. No, this is not complicated, guys. All this means is that 1 cm cube of the material is equivalent to 2.2 grams of the material. That's all it means. 2.2 grams per cm cube means that every cm cube have this amount of mass in it. 2.2 grams. It's not complicated. That's all that this means. 2.2 kilograms per cm cube. So 2 cm cube have 2 times this. 3 cm cube have 3 times this. So it means that this volume of material, you have to multiply by 2.2 to get it in grams. But understand that. Good? It says, determine the mass of the empty container. That's of the material alone. Empty container. So the mass of the empty container is the mass of the material when the container is empty. So see here now, mass of material equals, using this ratio, 1 cm cube is 2.2 grams. So it means that we're going to multiply this by 2.2 grams, this. All right, to get the mass. So it's this amount times 2.2. 11,553 times 2.2. 11,553 times 2.2 grams. All right? But I want it in kilograms. So when you get the answer, we divide by 1,000 to get it in kilograms, right? So get it in grams first. So it becomes 11553 times 2.2. We get 25416.6 grams first. To get it in kilogram, they divide by 1,000. 1, 2, 3. That's 25.4166 kilograms. Three significant figures, 25.4 kilograms is the answer. That is it. You give them three significant figures. If you leave this, then give it a marks to them. Don't worry about it. We tend to give answers that are not exact, the three significant figures. But I go to that, that's in kilograms. All right, let's move on. Don't come to this pattern question. Easy, quick and fast. It says the sequence of figures is made by joining polygons with sides of unit length. It means that each of these little lines is 1 unit, like 1 centimeter. That's what it means by unit length. All right. It says the first three figures are given. First three figures in the sequence are shown below. It says must draw the figure 4. So to draw figure 4, you can draw figure 3 and then we'll add on back one of these things on it, right? Let's add on back one of those things on it. So we can draw figure 3. So trace figure 3, and we're gonna add one more onto it. That's pretty obvious. Notice that these are broken lines in here, inside. So I'm gonna draw about the shape. So let's draw it straight. This piece has to be broken now. So I'm gonna take it out back and put it broken. All right. And then I'm gonna add on to that. I'm gonna add on to this shape. I'm gonna add this shape onto it. This is what is added. It's like I add this onto each shape. All right, so I'm going to put this in a different color. So that's what addition is. So I'm going to take this and add it onto figure 3. Like that. I'm going to put a broken line in here now. This line I'm putting a broken line in here now. That is my shape, a figure 4. So it's figure 3 plus one more of those things. That's my figure 4. Oh, I need this broken line down here. Sorry. I need this broken line down here. The broken line down here. A broken line down here. I'm not sure about this broken line, this one. In it. A broken line down here. But again, that's figure 4. Figure 3 plus the red piece. Make figure 4, right? This is figure 4. Simple as that. Next question. It says, study the pattern of numbers in each row in the table below. Each row relates to one of the figures in sequence. So some rows have not been included in the table. Complete the rows for 1, 2, and 3. Same thing I ask all the time. I like to do the number line, the formula line first. So observe the pattern. All right, so here is that this number and this number matches, right? They're always adding to 2 in the middle. And then this number over here is 2 times that number every time. So it's basically doing that. So it becomes n is the first number. First number is n plus 2. The middle number is always 2. Plus this number is always 2n. So if you combine all of these, it becomes 3n plus 2. 2n plus n is 3n plus 2. So it works out to be 3n plus 2. We could also get this 3n plus 2 from the column itself, you know. Because remember now, these values increasing by 3. So the formula would start at 3n as normal. And the first figure actually has 5 in it. So 3 times 1 is 3. 3 plus 2 is 5. So you get the formula from the column by itself anyway. We get it out of these. Any way you want to look at it, that becomes a formula. 3n plus 2. All right, so based on that, now we can complete this line for 6 by putting it here, and the 6 here, and the 6 here. Now work it out. So it's going to become 6 plus 2 plus 12. 6 plus 2 plus 2 times 6 is 12. But I give you that. Good. And if you add up these, you how much again? You can put it here, you get 20, don't it? 3, 6 are 18. 18 plus 2 is 20. Or if you add up these, you get 20 same way. Anyway, take it, this is 20. Then for here, for this line now, you want to work out what the n is first. So to work out what the n is, you have to put this formula equals 65. So I'm going to put the formula equals 65 right here. I'm going to put 3n plus 2 equals the 65. Subtract the 2, you get 3n equals 63. Then divide by 3, you get n equals 21, don't it? So the n right here says 21. Take the 21 and drop it on this. Oh, I'm going to put the 21 in this formula now. In this formula. So in this formula. So it's going to become 21 plus 2 plus 42. 21. Middle value is always at 2. Plus 2 times this value becomes 42. And I'm supposed to add up to 65 and check it, which is correct. But all right, that's the table completed. Next part now. Show that no figure can have 100 units. So now it shows that a formula can't equal 100 with a whole number n. N has to be a counting number. That's a whole number. N has to be a natural number, counting number. So you're gonna try to see if 3n plus 2 can be equal to 100 with n a member of natural numbers. N has to be a natural number. Is it possible for n to be a natural number and this equal 100? So start to solve. We get 3n equals 98. By the 3, you get n equals 98 over 3. N equals how much? How you do that? 98 divided by 3. You get 32.6, which is not a natural number. Yeah? Like n has to be a natural number, a counting number, it has to be a whole number. So when the formula has 100, you're getting a number that is not a natural number. So none of the figures can have 100 dots, right? Therefore, no figure not dots. As a perimeter of 100 units. That's it. But good? No figure that perimeter of 100 units. But the n that will make it equal 100 is not a natural number. Right? It's not a natural number. That is it. And you could do it as well. Work out what the perimeter would be for n equals 32, and what the perimeter would be for n equals 33. And see, jump over 100. You could do that way as well. But this is a good enough. All right, let's go. Now, section 2. All right, we have 3 questions to do. What's time? It's no, that's wonderful. Let's finish this jiffy. Next 3 questions. I'm sure we do them questions multiple times already. This class. Well, let's go. Question says, compute the table for this function. Remember that a quadratic function, because of the negative, you know, it's going to have a front shape. It has a front shape that has a maximum value and a maximum point. Remember, the values are symmetrical about symmetry. So I'm looking for values that are the same. For example, this and those are the same. And these same interval, these x values are in the same interval. That we're in. So it means what this one come into, this one come into the same thing. So I'm sure that right is going to be a 3. I was trying to go out to, this one go out to the same thing. So I know that this one going to be a -5. And the values are symmetrical. So that is 1 mark for it, you know. So if I do it that way, they can't penalize. It means that this is my axis of symmetry, you know, right in the middle, you know. See it? I said 3 to 3. So this is my axis of symmetry right here. That is my maximum point. That's my vertex. That's my maximum point. Is 1, 4. That's my vertex point. All right? The vertex point is always the point where the y values don't repeat. So the 1 point that have this maximum 4. Notice all these values repeat. The 3 to 0, the -5, the 3 to 0, -5. Right? Those y values occur at 2 different points on either side of the axis of symmetry. So the axis of symmetry is x equals 1 right here. That's what the level I want you guys to understand this thing. Understand that there's an axis of symmetry, a vertex point. And the value, the y values are symmetrical about that axis of symmetry. So remember, these y values are symmetrical. 305 that way there, 305 that way there. On either side of the axis of symmetry. Axis of symmetry pass through this point. So that x equals 1. X equals 1 is the axis of symmetry. X equals 1 is the axis of symmetry. The values are symmetrical. I use a 0 as my reference to know what these are. But if you want, you could work this out. You could work this one out, for example, by putting -2 in that. And work this one out by putting 2 in that. But look here, it's only 1 mark for this question. Who wants to be doing so much thing? They can look for the symmetrical nature of the values. The values are symmetrical, remember that, from the axis. All right? All right, maximum point. Let's continue. Then we want us to sketch a graph. Sketch a graph. So this is my maximum point right here. So this is my axis. Axis of symmetry is this line passing through the maximum point. It's my axis of symmetry. That ready. All right, so the values are symmetrical about it. So, for example, this one is 2 units here, so there's a point corresponding to it on this side right here. And this one as well. 1, 2, 3, 4. Gonna go 1. Oh, it's here already. 1, 2, 3, 4. The axis continues down, so I can extend it down. That's still the axis of symmetry. So this point out here is 1, 2, 3, 4, 5, 6. Corresponding point gonna be 1, 2, 3, 4, 5, 6 right here. So I can better it up is -2, -5 in the table. -2, -5. See there? -2, -5. So those are the points. I was going to draw a smooth curve through those points now. I need a smooth curve through those points. Let me see. Let me see how best I can do that smooth curve. So this half of it is like this. This half of it is like this. Draw it up. Come on, Now, give me a curve, please. All right. Something like that. Let me draw it over this side. Let's draw it again. Let me draw it over. Give me that side, all right, but it's not giving me the right side. All right, let's work with that. And this is supposed to be a turn. And that's straight line. It's supposed to turn, a maximum turning point. So we're supposed to sharp like that. Turn, a turning point like that. Oh, but I missed this one. See, one is missed. I have to do over this half of it. That one is missed, guys. It's not passing through this. I'm going to leave it like that. We're supposed to be smoother than that, right? The bar is not friendly to joint. That is it. I'll leave it like that. Next part now says, using the graph with the coordinates of the maximum point. We have it already. It is right up here. 1/4. All right. Coordinate of the maximum point is 1/4. Then it says range of value for which f of x is greater than 0. What that means, where am I? Where am I? Where am I? Where am I? Hey, outside me. F of x is greater than 0 is where your y value is greater than 0. That's what this means. Where your y values, this means where your y values are greater than 0. That means above the x-axis, above the x-axis, the y values are greater than 0. So it's talking about up here. In purpose, it's talking about up here. Everywhere up here, the y values are greater than 0. Y values are greater than 0 everywhere up here. That's between these two x values. Between this x value and this x value. Any x value in between these two x values, the y value is greater than 0. You can see it. For x value in here, you're above the x-axis. For x value in here, you're above the x-axis. Once your x value is between these two values, your y values are greater than 0. In between these two values, your x is less than this one, less than 3, and greater than -1. Greater than -1. That's the answer. X value is between -1 and 3. So y values are greater than 0 when x values are between -1 and 3 right there. So the answer for that is this. X between -1 and 3 down here. That's what this is. When the x value is less than 3 but greater than -1. That's when the y values are greater than 0. That's what that is talking about. F of x greater than 0 means that. Means the y value is greater than 0. Means that the graph is above the x-axis. The graph goes above the x-axis once the x is between -1 and 3. Once the x is between -1 and 3, notice the graph goes above the x-axis up here. Once your x value is between these two. That is it. Next part says the gradient at x equals 1. X equals 1 is the maximum point, don't it? X equals 1 is at the maximum point. That is at maximum point 1/4. That's right up here. And the maximum point of gradient is 0 because if you put a Remember, when you have a curve and you want to find gradient, you have to draw a tangent, right? You have to draw a tangent. That to be a tangent at x equals 1. Gradient of a curve is gradient of a tangent. That's a horizontal line. Gradient of a horizontal line is 0. That's a horizontal line. So the gradient at this point is 0. So the gradient of that line is equal to 0. Gradient of a horizontal line is 0. So gradient of a curve at this point is gradient of that tangent, which is 0. Horizontal line is a gradient of 0. So see it here. Gradient of f of x at x equals 1 is the gradient of a tangent at the maximum point. Gradient of a tangent. That equals gradient of the tangent at x equals 1. That's a i.e. horizontal line. Horizontal tangent. Tangent is horizontal. Therefore, gradient equals 0. Horizontal lines have a gradient of 0, and there's no rise. There's no rise on horizontal. The gradient is 0. Rise up, man. Rise up. You're late and you're sleeping. I'm going to call the mother in. Rise up, man. Sleeping duty. Not sleeping. Let me say not sleeping. Next one. Mrs. Thomas makes X bottles of juice and Y cakes each day. X juice and Y cakes. To supply his customers, or is that Mr.? To supply his customers, he makes at least 20 bottles, at least 20 juice, and no more than 15 cakes. Right? Two inequalities represent this information. All right. So the number of bottles X must be at least 20. At least 20 means 20 or more, don't it? This means greater than or equal to 20. So the number of bottles of juice must be greater than or equal to 20. That's what at least 20 means. Right? Greater than or equal to 20. Device not cooperating. Then now it means no more than 15 cakes. No more than 15. 15 is the maximum. No more than 15 means less than or equal to 15. Can't pass 15. So number of cakes, which is Y, has to be less than or equal to 15. Those are the two inequalities. X has to be 20 or more, as is at least 20 juice. It's 20 or more juice. But it's a maximum 15 cake. So number of cake about 15 or less. Because 15 is the maximum. No more than 50. Can't pass 50. 15 or less. So number of cakes has to be 15 or less. Number of juice is 20 or more. That is it. That's the two inequalities. Two inequalities. Next part says, each day, Mr. Thomas uses $163 to make the juices and the cakes. So $163 is the maximum money we have. So I'm either going to spend the full $163 or less. Good. It says, the cost to make the bottle of juice is $3.5. That's to make one bottle, $3.5. And it's making X of them, right? So this amount times X for the juice. And the cost of making a cake, as one cake, is $5.25, and it's making Y cakes. Therefore, the money that he's spending on the cake is this amount times Y. It says write an inequality to represent this information. So is the money for the juice plus the money for the cake has to be less than equal to this amount of money. So tell me if you see this now. So it's 3.5. That's the money for the juice. Plus 5.25 Y. That's the money for the cake. Can't pass the amount that he has, 163. But understand that? Understand that? The bottle money, the juice money, plus the cake money have to be less than or equal to 163. That's inequality. What's more than for that? 2 marks. Do you understand that? Any explanation for it? He's making X juices for this amount of money each. He's making Y cakes for this amount of money each. This is total money for the juice. It's total money for the cake. You add them. Must be less than the amount that he has. Right? I don't know what explanation to do for this. I just straightforward. Right? So let's write it this way. Juice cost plus cake cost. Juice total. Total money for juice. Juice total plus cake total. Has to be less than or equal to the money that he has. $163. So the juice total is this. That there were X juices at this amount for one juice. See, a bottle of juice is this. And it's making X juices. And it's making Y cakes at this amount. Right? So that is it. So the juice total is this. The cake total is this. And the total money I have to spend is this. You can't spend more than he has. So that's inequality right there. 2 marks for that. Next question. It says, show that on any possible form to make 50. So this is when 50. And this is when Y equals 12. Once the total money that he uses to spend that amount, right? And see if it passes 163. Can't pass 163. If it pass 163, it can't make that, don't it? See that? So for this amount, total would be, remember that he's spending X cakes at $3.50, right? 50 bottles at $3.50. And this is one is at, what you spend for this again? $5.25. So the total that you would spend over here so would be 50 times $3.50 plus 12 times this plus 12 times 5.25. Let's see what this would work out to. So it's a calculator and work this out. So that amount would be 50 times $3.50 plus 12 times 5.25. That's $238. So that he only has $168 if he can't make that. So that he needs $238. I'm right, amount needed here. Amount needed. How much money you need? The amount needed is 238. He only has 238. Only has 168 in charge. If we can't make it. See that? So not enough money. Cannot be done. Cannot be done because there's not enough money. Cannot be done. Not enough money. Can not have enough money to do it. He needs 238 to make 12 cake and 50 juice. He only has 163. 163, not 168, 163. He only has 163, not 168, 163. Remember them say only spent 163. That's why I'm can't, right? Now have enough money. Done. Number 9. Circuit theory. diagram. I need my calculator. I need my calculator out or running again. Let's see. I don't need this. Need my calculator for this. Trigger have a check question. And the question says, diagram below on John's scale shows a circle. The points P, Q, R, T, and V are in the circumference. QRS is a straight line. No, that's not a tangent. You can't use tangent rule on it. It's not a tangent. So you can't treat it like a tangent. Guys. Right? So we call it secant line, not a tangent line. It says PV, angle PVR is 75 degrees right here. And angle TRS is 60 degrees right here. No, that's not a tangent and a chord. It's not a tangent. It's not a tangent. All right? It's actually the external angle. It's actually the external angle of the cyclic quadrilateral. External angle of that cyclic quadrilateral. But anyway, it will work out itself. It said, determine the value of each of the following angles. Show detailed working where necessary and give a reason to support your answer. First angle I want is angle PTR. PTR. That is angle up here, so the one. PTR is this angle up here, so. What did we say? If you can't find the angle, right at the bottom, find the chord or the arc that is subtending the angle. How you find it? Come back till you reach a circumference. Come back along the sides, form an angle to reach a circumference here. Come back along this one till you reach a circumference here. I don't see a chord there. So it's an arc that is subtending. When you don't see a chord, you look for the arc. So this arc over here is what is subtending that angle up here. The same arc, this same arc is now subtending this angle up here. So same red arc is subtending this angle up here. So both of them subtended by this arc. And they are in the same segment. And so those two angles are equal. Same segment rule. They are subtended by the same arc. So it means that this angle up here that I want is 75 degrees. All right? So that angle is 75 degrees. Let's delete this. So this angle up here is 75 degrees. Same as that one, because both of them subtended by that arc. So this angle is just 75 degrees. Same segment rule. Angles in the same segment are equal. When we'll stop here, so if you want to know, we'll stop right there. Angles in the same segment are equal. You can say when subtended by the same arc. This case, the arc. It could have been a chord as well, or chord. That's it. Angles in the same segment rule. Next question. Angle TPQ, angle TPQ, where's that? Angle TPQ. TPQ, that's this angle over here, so. All right, so now I want to find this angle. All right, I want to find that. But see that angle, it is opposite to the here in the cyclic quadrilateral. Those two angles add up to 180 degrees, don't it? But then now this angle is on a straight line with this 100 with that 60-degree angle. Total angle on a straight line is 180 degrees, don't it? So this angle, therefore, is 120 degrees. That's all. And if that angle is 120 degrees, and then two you must add up to 180, then this angle is also 60 degrees, don't it? See that? But there's a rule that says the external angle of a cyclic quadrilateral is equal to the opposite interior angle. Whatever good that rule, let's take, because these cannot always be figured out. So we can find the angle here so by saying that 1 here is 120 because of the straight line. And then these two add up to 180. That's why this one is also 60. All right. So that's the premise on which we'll do it. I'm going to use the external angle of a cyclic quadrilateral rule. That's external angle of a cyclic quadrilateral. Let me draw it out for you. This is your cyclic quadrilateral here. I'm drawing out in blue. And this angle out here is the extension on one side. And that angle on the extension is an external angle. It is equal to the opposite interior angle across here is 60 degrees. So we can say the external angle of a cyclic quadrilateral is equal to the opposite interior angle. For the simple reason that angle on a straight line is 180, this is a 180, and then them two across each other is also 180. See that? So the angle out here and the angle in here must equal. Let's use that rule, man. Come class for learn. Learn. External angle of a cyclic quadrilateral is equal to the opposite interior angle. External angle of a cyclic quadrilateral is equal to the opposite interior angle. That's why this angle over here is 60 degrees. Because this is an exterior angle. Why is it an exterior angle? Because it is on the extension of one of the sides. And the exterior angle formed with the adjacent side to it. I'm gonna write that through. It is 60 degrees. So the mathematics is the easy way. Why write a more complicated rule? It's equal to the 60-degree angle over there, so. So the angle in here, so, is 60 degrees like that one. Because the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. Let's write that. The exterior angle, so rule number 8. We have 7 rules for 8 one. Exterior angle of a cyclic. I did tell I would have give you one more rule. Told you. Quadrilateral is equal to the opposite interior angle. That's the reason. So when I thought the topic, I just left out this one because I know it don't come very often and I know it can be worked out, can be figured out. But just know the rule and use it easier rather than to write 3 different things to get it. Hey, since I'm come class next time, I put one box on the phone. On the paper, the name on it, and put it on the desk. Because we have serious addiction. It's very, very sad on the phone. I don't want to pass people with that poor habit there. The exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. You make teacher life hard, you know? Teacher life difficult, I tell you now. You become class with teacher and have to participate. So foolishness and I don't supposed to be big children. Question 7 must find the obtuse angle POR, where O is the center of the circle. Let's go and put it in the center of the circle. They didn't show it to us, so we have to put it in. So I'm going to take these out. So just work out that this angle over here is 60 degrees. Let's leave it there. So the center of the circle, they didn't show it to us. Let's put it on where it would be. Put it on anyway. So this is the diameter. That's a diameter. Center the way about here. Let's put the center somewhere more mean. So let's say the center is here. O. That's at the center. Let's say this is the center O. And I want the angle POR. That's what I want. POR. I put down in blue. I want us to get in this angle. P to O to R. So they're asking us for this angle now. It's called theta. That's the angle at the center. Don't it? O is the angle at the center, don't it? That angle O is subtended by this arc from P to Q, from P to R. Good? That angle at the center is subtended by that arc. The same arc is subtending this angle at the circumference. So the center rule say. The center rule say. Angle at center is twice angle at circumference. I could have put in a chord if I wanted to say a chord, and I would see it better. So the angle at the center is twice angle at circumference. Angle at circumference is 75. One at the center is twice as much. Remember that rule? Remember, not only a chord can subtend an angle can also be subtended by an arc. So the arc there, this arc is subtending this angle at the circumference, 75. The same arc is subtending this angle at the center. Angle at the center is twice angle at circumference. So center rule. So this angle is 2 times this one up here. So angle at center is twice. You're asking us for an angle at the center. You must remember that rule. It's twice angle at circumference. Both of them subtended by that arc. From that point. It's simple as that. It's 2 times 75 degrees. So that angle that we're going to call it theta on the diagram. That's the one. Right? And theta is equal to 2 times 75 degrees, which is 150 degrees. Center rule. Theta is the angle at the center. Angle at center is twice angle at circumference. That is, both of them subtended by the same chord. When subtended, same arc, they're both subtended by the same arc. When subtended by the same arc, or it could have been a chord or a chord. Because we could have drawn the chord in the diagram for one, right? So put a chord across here. So then at the center, subtended by this chord, same chord is subtending this angle at the circumference, which is 75 up here. Same chord is subtending the 75 at the circumference. So we could have gone that way as well. But the arc does the same thing. That is it. So that angle at the center is 150 degrees. Twice this one. Angle at the center is twice. All right, next question. This question about mistake. Because they said the angle of depression of angle of depression of S1 and S2 are 12 and 20 respectively. So this is the further one. So this would be angle of depression. This would be the 12 degrees. And this would be the 20 degrees. So 12 degrees corresponds to S1, but I have S2 on the diagram here, so this has to be S1. I did give you the right here on the paper that I printed. So this is actually S1, the chain. So this is S1. This is S2. And that happens sometimes in exam, be smart when they see that. So this is S1 and this is S2 on this exam paper. Alright? So remember, angle of depression from the top equals angle of elevation from the bottom. So question says a person stands atop a lighthouse, at the top of a lighthouse, TD, the lighthouse here, and sees 2 ships, S1 and S2, approaching the coast as illustrated in the diagram. Angle of depression, angles of depression are 12 and 20 respectively. 12 and 20. The further one has the lowest angle of depression, which is from the horizontal looking down. So this angle is 12 degrees looking down to S1 and 20 degrees below the horizontal looking down to S2. It's 20 degrees. Remember, it's like a form of Z. So if the angle of depression looking down is 12 degrees, the angle of the elevation the other way is 12 degrees. So this angle inside is 12 degrees looking up. Same angle over here is 20 degrees looking up. So angle of depression looking down is 12. Angle of elevation other way is 12. Angle of depression looking down here is 20. Depression is 20. Angle of elevation looking up is the alternate angle, because this line is horizontal and this line is also horizontal. So you form the Z angles. Form a Z angle here, and you form the other Z angle here. And that's equal again, right? All right, I'm just repeating these things for revision purposes of all that I've said it before. They said this number 2 meters. So I mean that this distance is 110. Let's put on the diagram. This distance is 100. All right. So that distance is 110. Now, since this angle is 20 and this is 12, the angle between these two lines is, let's put that in the diagram. This angle inside here, so it's 8. So this is 8 degrees between them. That's 20 minus 12 is 8 degrees between these two lines. And the question now, TS2 is asking us for this side right here, TS2, this side. So we're going to work in this triangle. That's not a right angle triangle, so we're not going to use sine rule or code. We're not going to use so-called or Pythagoras theorem. So what we're going to do, we're going to use this angle with this side, and use sine rule, and use this angle with this side. So let's say the side that we want, TS, we're going to call it X in the diagram, X. Let's call that distance X on the diagram. I'm going to write this in blue. I'll leave it in red, no matter. So I'm going to use sine rule. This angle with this side opposite each other, and this angle with this side opposite each other. Sine rule. I'm going to use sine rule in that triangle. The sine rule for X. Sine rule for the X. And so it's going to be X over the sine of the angle opposite to the X is the 12 degrees equals the side that we know, the 110, over sine of the angle opposite 110 is the 8 degrees. And to find the X, you're going to take the sine of 12 and multiply it up here. Always put trig behind the numbers when you multiply. It's going to be X equals 110 times the sine of 12 degrees over the sine of 8 degrees. Work that out, we have that distance X. Let's do it over here on the calculator. So it's going to become a fraction, 110 times the sine of 12 degrees over the sine of 8 degrees. Why am I getting that? Oh, the calculator is in radians up here. Oh, we're doing a trick question and get radians. You should be doing that. Calculator in radians all the time. And you be doing a trick question, I doubt it too. No, we're not doing a trick question. Calculator was in radians all the time. Wow. You do a trick question. Nope. Just checking. Calculator, you see the R radian top of the calculator there? It was in radians all this time. You make sure you calculate in degrees, you know. My calculator is going to go in radian because I teach pure maths and add maths. We do the calculation in radians. No, we never do no tricks, thank God. We never do this sign and cos and anything like that. All right. maybe I would have known though, because I would have get a value that is not correct, as I have here. So negative 1, negative 59, I know something wrong right away. Calculator is in radians, it's supposed to be in degrees. So I'm going to change. So it's 164. And I can't change the calculator to degrees. So that becomes 164. That distance is 164. All right. I said to the nearest meter, I mean, say don't put a decimal. Let's run to the nearest whole number. That's 164. What is that? Meters. 164 meters. All right. So 64 meters it is. All right. Next part says we have to calculate the height of the lighthouse. To calculate the height of the lighthouse, can work in this triangle now. And the height of the lighthouse is TB. TB. And we can use sine of this angle equals opposite over hypotenuse in that triangle. Sine. That's a right angle triangle. Just going to use that. Sine of 20 equals TB over 164. That is it. So sine of 20 degrees equals TB over 164. And then take the 164 multiplied up here, you get TB. 164 times the sine of 20 degrees is equal to TB. Therefore, TB equals, so it becomes 164 times the sine of 20 degrees. That's 56. Nearest meter, that's 56 meters. Like the stand, it's the nearest meter. Done. One last question. For the day. Last question for the day, guys. Last question for the day. This question says 3 matrices PQ, 3 matrices are given, PQ and R. It said by calculation, by using a calculation to support your answer, explain whether P is singular or non-singular. So you have to find the determinant of P. If it's singular, the determinant is 0. If it's non-singular, the determinant is not 0, right? So the determinant of P equals this product minus this product. That's negative 1 times 5 minus 2 times 0. The determinant of P. That becomes negative 5 minus 0. That is equal to negative 5. Negative 5 is not equal to 0. So it is non-singular. Therefore, P is non-singular. But the determinant is not 0. If the determinant is 0. So P is a non-singular. Look at what it was 0 would be singular, but the determinant is actually negative 5, which then means that it has an inverse. When it is non-singular, it has an inverse. For P and inverse. So in other words, you can work out P to the minus 1, right? That's it. P as an inverse. Next one. All right, given that PQ is equal to P and P, PQ is equal to R. So let's set it up. P times Q is equal to R. So P times Q is equal to R. Let's put in the values. Put up here now. P3 is equal to R. Let's put up here and copy it down. So minus 1, 2, 0, 5. That's P. Q is AB. Is equal to R, which is 11, 15. So the classic equation. Let's copy this down. So that's PQ equal to R, right? If PQ equals R, guys, you're supposed to know, write it over here, so. If PQ equals R, and try to find Q, and Q is going to be P to the minus 1 times R. Take the Q and multiply it in front of this, and it becomes the inverse. That's the premise on which we're going to do this calculation. Right? If PQ equals R, then the Q equals the inverse of P times R. So let's say that take the P and bring it in front of R, the inverse in front of R. So we need the inverse of this in front here. So that you get the AB. It's a classic equation. So let's write it out here. So AB is going to become minus 1, 0, 0, 5, no, minus 1, 2, 0, 5 to the minus 1. Put the minus 1 at in red. To the minus 1. Mean the inverse of this coming in front of the 11, 15. So I have to calculate that inverse right here. So this is the inverse I bring in front of this side. The same calculation I work here. So this is the P to the minus 1. I put them on in here for you. So this is the P. This is the P to the minus 1. So the minus 1 here. P to the minus 1 I want. I have to work out the P to the minus 1 now. See that? Which is 1 over the determinant times the adjoint, right? Right, okay. So P to the minus 1 is equal to 1 over the determinant of P. 1 over the determinant of P times the adjoint of P. That's what calculate P to the minus 1. We already have the determinant up here. It's negative 5. We don't have to work it out again. Determinant of P is negative 5. So then this AB becomes equal to 1 over 5. Determinant of 5. Determinant of P is already negative 5. Negative 5, right? Negative 5. Times the adjoint of P now. The adjoint of P. I'll get the adjoint of this matrix P. Interchange these two elements. So put the 5 up here and the minus 1 down here. You leave these two where they are, change the sign. So take this 2, change it to negative 2. And this 0 don't have no sign. 0 don't have no sign, so it's still 0. They multiply that by the 11, 15. And when you do this calculation, you always work with these whole number values first and leave the fraction out here for last. So we're going to be multiplying this 2 by 2 by this 2 by 1. We'll multiply matrices again. Multiply the rows of the first matrix by the 1 column. So multiply these 2 rows by this 1 column. All right, so let's set it up. So it becomes equal to 1 over negative 5 times a matrix with 2 values. 1 here and 1 there. How we get this value again? Because it is in the first row and the first column, we multiply this first row by this first column to get it. How we multiply it? First element in the row by the first element in the column, and second element in the row by the second element in the column. So it's first element times first element, second element times second element. First element times first element, second element times second element. So it's 5 times 11 and minus 2 times 15. 5 times 11 is 55. And minus 2 times 15 is minus 30. And this value down here is positioned in the second row and the 1 column. So to get it to multiply this second row with this 1 column, multiply them the same way. First element times first element, second element times second element. So 0 times 11 and negative 1 times 15. So it's 0 times 11 is 0. And negative 1 times 15 is negative 15. This reduces to 1 over negative 5 times, this becomes 25. This becomes negative 15. So then this now becomes what? Is 25 divided by negative 5 is negative 5. Negative 15 divided by negative 5 is positive 3. That's what the AB is equal to. So it means that A equals negative 5. You write the solution here. So solution is A equals negative 5 and B equals 3. B equals 3. And that is the answer right here. Very good. Next one says, state a reason why the product QP is not possible. Because they are not conformable. Write it out, right? So Q is a 2x1 matrix, column matrix, right? See there? And P is a 2x2 matrix. So down here, let's just show it. We would have a 2x1. That's a P. That's a Q, sorry. And the P is a 2x2. And what happens now is that the number of columns here and the number of rows here are not equal. For it to be possible, the number of columns in the first matrix must be a matrix. Those two numbers are not equal. So you say that they are non-conformable. All right, so QP is non-conformable to multiplication, is non-conformable to multiplication. Because the number of columns in the first matrix, which is Q, number of columns in Q is not equal to the rows. The second matrix P. That's why it is not possible. That's the reason why it is not possible. That's a non-conformable. Number of columns in the first matrix Q not equal to the number of rows in the second matrix P. It's not conformable. That's the reason. All right. We'll come to the vectors. Last one. OABC is a parallelogram. A parallelogram. I want to see that the opposite sides are equal vectors. So these two sides are equal vectors, and these two sides are equal vectors. Remember that in a parallelogram, opposite sides are equal vectors, because the opposite sides are parallel and equal in length. It says OA is R, the vector R. Let's put them on the diagram. Let's put them on what they said. So OA is R. And you see, they know they don't put another points for you. B and C. But if you go O to A, you can't put B down yourself. You can't do that. You have to maintain the orientation. Right? So once you put A up here, it means that you have to put B over here. You have to maintain the orientation. B has to be here, and C has to be here. You can't put them the other way around to be wrong. You have to maintain one orientation when you're labeling an object. That is standard. All right? So the B has to be here and the C has to be here. You can't put B down as and C up as. No, we cannot do that. Everything is going to be wrong if you do that. It's understood. Orientation must be maintained. All right. Let's put on the vectors now. So it says OA right here is R. So the vector from O to A up here is the vector R. So it means that C to B is also R. Let's put it on there. This vector is also R. All right. Then it says OC is S. That's vector out here is S. So put it on the diagram. This vector out here is the vector S. So the vector up here is the same S, parallel and equal to length. This vector therefore is also S. All right? It says now, given that OX plus OY is equal to K times R plus S, where K is a constant, use a vector method, find the value of K. So all we have to do is work out what this actually is and compare it to what they gave us to see what the K is. That's all we have to do. Work out what the OY, they tell us about X and Y. X is the midpoint of AB and Y is the midpoint of BC. I would never put them on here. Let's adjust the diagram somewhat then. Let's adjust the diagram. So the midpoint of AB is X. X is the midpoint of AB. That's up here. So let me take this off there. So right up here says X. So if the whole thing is S, then it means then that right here, so it's half of S. And right here, so it's half of S. And that's the midpoint. It cut S in half. Half S and half S. And then Y is the midpoint of BC. That's over here. BC, right? So again, we'll divide this. So it means that right here is Y. So then we have half R and half R again. This becomes half of R. This is another half of R. But the whole thing is R, as it is over here. All right. So we have all the thing on the diagram. Let me say now OX plus OY is equal to this. So let's look at the diagram and say we'll get OX and OY. So OX would be this plus this. Simple as that, right? Good? That's what would be OX. So OX plus OY would be equal to, let me shift this over, would be equal to the OX is clearly R plus half S. But you can see that? Okay, you come up here so and then go there so. So you get R plus half S is the OX part plus the OY part now will be S plus half R. Can you see that? You go from O to Y, where you're gonna come out here so with the S first and then go half R. So it will be S plus half of R. We consolidate the values. The R values first. That's R plus half R. That's 1.5 R, which is 3 over 2 R. 3 over 2 R. And then half S plus S. That's 1.5 S again. That's plus 3 over 2 S. You can factorize the 3 over 2 now to get an expression looking like this. So you factorize the 3 over 2, get 3 over 2 into R plus S. And they tell you that it is equal to K times R plus S. So remember this was K times R plus S. That's what they said, right? They said it was K times R plus S. This is what was given. So it means that K over 2. Yeah? K over 2. So it's find the value of K. So we worked out and we get K over 2 times R plus S. And they gave us K times R plus S. That means that K is equal to K over 2. You can write it down here in purple. So therefore, K equals K over 2. That is the answer. Oh, and that is it. End of this step. Hey, I tell you, no, come back to my class, you know, some morning, you know, not joke, you know, no, for this set, you know. We don't come class to leave, we don't come class to do no rush. Huh? No, seriously. So when I come up and learn, we just come class to come see it. Huh? R. Just underline the R. It's R. Hey, look here, look here. Hey, look here. Everybody's from next week, you're not going to tell me what you're going to get, yeah? From next, you're not going to tell me how much you got, the paper. From next week, huh? Yeah, man, yeah. Yeah. You put R, you got this. You put this. Yeah, man. You from before, then you're still right. 1.5, still right. 1.5. All right, guys. That is it. Online people, you're good. I'm not hearing from any of you. Y'all okay?
Yes, sir.
All right. So from next week, everybody going to have to tell me the grade. From next week. So we have to get on track. From next week. All right. Same thing you got wrong, make sure you do it over. Do over the question y'all got wrong. Remember, we're doing another paper tomorrow evening. The other paper is tomorrow. All right, bye, everybody. I share this in the group afterwards. All right, I'm going to send it now. All right. Yeah, cool.